So, it's been a long day. We've talked about a lot of different things, and we focused primarily in the morning on this notion of business value and how it affects businesses and how you want to think about products. And we've been talking this afternoon about this notion of implementation detail, like what is it really like to have an API as a product, and what is it like to design something that people are going to have to deal with and work with, not just value, but usability or desirability. And then you heard the panel talk about a lot of details going into the process of keeping one alive and documenting it and make sure it's the right design and collecting all that stuff up. One of the themes through here has been this notion of action. It turns out your data is really not worth much. You know, it's what you do with it, it's what happened to create it, and it's what you can do now that's actually the real value. I want to talk about data, and I'm doing this from a viewpoint of saying open data. So we know of open data from government ideas. We work a lot with state, local, federal governments. We also have a lot of open data available to us, map data. There's all sorts of data that we can use in our own business to enhance what we do. But that data actually has to be usable, and that's really what I want to focus on. I want to focus on this notion of usability. So Ronnie talked a little bit about this, and I want to drill in a little bit deeper about this notion of the learnability of human-made objects, because that's really what we're stuck doing. We're creating things that don't really exist. And I'm going to invoke Donald Norman just like Ronnie did. Ronnie actually just tipped me there's a new edition of the Design of Everyday Things book. It was first published in 1988. So it's 25 years ago. Last year, a revised and expanded edition was released by Don Norman, and it's incredible. I'm having so much fun reading it. This is definitely a book you want to read. This is an enjoyable read. It's a short read, and it will affect you a lot. So he talks about Norman doors and lots of other things that are really important. You might have noticed the front cover has this strange teapot on it. How would you like to pour out of that teapot? How would you like to pour steaming hot water out of that? Look where the handle is and look where the spout is, right? So there's this gentleman by the name of Carls who's invented all these unusable objects. A chair that lays down, right? A chess game that's on a globe. And there are many more of these. If you just go to this Impossible Objects site, you'll see many of these designs. And this really cuts to that notion of usability. They're pretty, but they're not really very usable. In fact, the thing that makes things usable is something sometimes is named an affordance. This is a word that maybe not everyone has heard of, but this affordance, this property of an object is really, really important. Actually, it's a word that was invented by a gentleman by the name of J.J. Gibson in the 80s, or in 1977, and he talked about it in the 80s. As a matter of fact, Gibson and Norman were friends. So Gibson's talk about affordance, the sort of innate ability for something to be used, really affected Norman. For instance, this chair affords sitting, right? But it also turns out it affords throwing. There are lots of things I can do with this, right? So it's that affordance, that ability to use something to get something done that we're talking about, and that Gibson talked about in his book. This is a picture of Gibson, and this is the book he released called The Ecological Approach to Perception. It's a very, very deep book. I will be honest with you, I've read it, and I don't understand it. But this notion of affordance in the world is really important. So affordance becomes this way that we think about how I can use things, and that's why we know it's a button on a screen and an input and all these other things. They have affordances. But there's a gentleman by the name of William Gaver who sort of threw a wrench in this notion of affordances. And it turns out there are things that affordance might exist, but nobody knows about it. It's sort of like that tree falls in the forest. Like, does it matter that it's possible for me to throw that chair if I don't think about it? Is that really an affordance? So he writes this paper about affordances and about things called false affordances or hidden affordances. And it really kind of changed a lot about the way people thought about usability. And he has a couple of things. He talks about a rejected affordance. That's not really possible to do. So here's a good example. I have a bottle of wine and a shoe. I need to open up the bottle of wine. If you hand me the shoe, I'm going to say, no. I reject that. The shoe does not afford opening a bottle of wine. That's silly, right? Can't you give me a corkscrew or something else? Perceptible affordances are the things that we always assume that we know about. And then Ronnie talked a little bit about this. Here's a door. This is a door with a handle. This is a door with a crash bar. This is a door that's a little confusing. Do I pull it? Do I push it? Right? That would be Ronnie's signifier, right? Like it's telling you something, but I don't even understand what it's telling me, right? There are also these notions of false affordances. False affordances are things that are there to make me feel good, but you don't really do anything, right? They're just there to make me feel good. You think the light will never change if you never press that button? Of course not. It's going to change just fine, right? By the way, I love some of these updates for these affordances. Push for luck. There's a good one. I don't know if I want to press that one or not. It's a rather dangerous signifier. So then we get back to this notion of hidden affordances, things that we don't really think about. Well, it turns out, thinking about this bottle of wine, you can actually use a shoe to open a bottle of wine. So you'll find this on the web. If you just look up how to open a bottle of wine without a corkscrew or how to open a bottle of wine with a shoe, you see a little film. You're actually using the shoe as a buffer as you jam it up against the wall, and it actually pops the cork. So it turns out there's a hidden affordance in that shoe. As Norman would say, maybe we need to add a signifier on the heel used to open wine bottle, but it might get a little confusing. So this notion about affordances and what's hidden and what's not starts to tell us about design and starts to tell us about the way things are usable. Usability is the perceived affordances, the things that we can find out, the things we can understand. So I'll get back to this in just a second. So I said I was going to talk about data. The characters and symbols and the quantities that we operate on. There are actually lots of versions of the definition of data, but I'm going to use this one because this is really the one that makes sense. My talk is a whole lot better if I use this one. So the symbols and characters, this is data. This is data. This is most of our data in our organizations. This is what it looks like. This is data, right? That's data, right? The usability is pretty low, right? Remember, it's not called an information base. What you have in rows and columns and tables and documents, that's just data. That's just data. How it's used is what's going to make a difference. And this notion about data different than information is actually really important, and it has a long, long history. So this is a picture of Claude Shannon. Claude Shannon is one of the people who's sort of the founders of the notion of the information theory or information age. He worked for AT&T. One of the things that he was working on towards the end of the Second World War is encrypted messages and making sure a message that's sent from A gets to B, and then make sure it's the exact same message that was sent. The problem is we send those messages as just, beeps and bops, and there was analog, so it was as waveforms. So we don't understand what the message means, but he invented a way to make sure that the exact same message that was sent was received. What he invented was the notion of the parity bit. Right? I'm going to do a check on this message, and I'm going to send it. I'm going to tell you to do the exact same check on the other end using the bit of information I sent you. If they match, it's the same message. Now, he used this idea of parity bit and checking to also figure out exactly how much information I could get over the phone line before I am getting too much noise or too much static. So we have quality phone conversations because of the work of Claude Shannon and a gentleman by the name of Weaver, who's also here. Now, what's really interesting is we get things like encoding of images, we get things like encryption, all because of this notion of being able to operate on data without understanding what it means. Most of our computation operates on data without understanding what it means. And that leads me to the third item in the list, and that's the model. The model is used as an example to follow or imitate. It's how we do things. It's the model that turns data into something else. So we start with this data, we come up with this model. We have lots of different ways. We model information using code, right? So we actually say, I'm going to take the data, I'm going to use some code, because that code is the model that will tell me what it means. Models allow us to add meaning to the data. Models plus data gives us the information we want. So if you think about it in real life, we actually just perceive data. Hearing and smell and taste and sound and all that's just input, that's just information. I found a really cool little GIF, little animated GIF of like, it's these little circles that are drawn so that when you look at them, it looks like they're rotating, right? You know, this little optical illusion. And what this GIF was, they had given this little print to a cat. And the cat would actually touch on it. The cat was seeing the same illusion that we see. I find that actually incredibly fascinating. The information that we get in has to get interpreted. And that interpretation happens in our heads. It's the same information everybody sees, but often we interpret it differently. If we're lucky, we share understanding with other people, right? I'm hoping that the way I'm speaking is fairly well understood for the rest of the people in the room, but it's likely that other people are getting information out of this that you might not be, right? Because we all have our own models in our heads. We know that models are really important because we can take the exact same information and see different things. That's why optical illusions work. That's why magic works. It's because it's the model in our head that tells us whether or not this is a young woman looking away or an old woman looking down, whether it's faces or a vase, whether it's a woman in silhouette with some hair or it's a man smoking a pipe. These are things that we do in our heads, and we can sometimes even flip between them because we change our model. Models are the powerful part, not the data. Data plus model is information. This gives us a key to start figuring out how we're going to design our information systems. We know that models are incredibly important. So it's information that we're after, it's not data. I can take the same data you have and find new information. I forget who the quote is from, but if you take in big data, if you torture it long enough, it'll tell you exactly what you want, right? You'll find exactly what you're looking for, right? So here, now we've got information when we took that data and that model, right? We had data, we had model, now we have information, right? We took the two together and now it means something to us, right? This might be, is this a recognizable model to anybody? Recognizable bit of information, the stadium? So I took the same information we had a minute ago and I added some spaces and color to it, and suddenly this looks a lot more usable because I've applied a model. It's no longer, this is the exact same information, but now it looks a lot more usable simply by adding spaces and color because we know what that model means. We know what the indent means and so on and so forth. So it turns out, here's the kicker, we can improve a lot of our usability on the information that we pass back and forth by adding these affordances. Affordances are what are part of the model. This is what I can do. I can read, I can write, I can filter, I can act upon, I can delete. So adding affordances is our way of improving the usability of information. It's adding models. So it turns out in computer systems, we can actually add those affordances, those signifiers, to the data itself. We can write on the bottom of the shoe, you can use this to open a wine bottle for those who are interested, right? That's metadata, right? So there's three ways we can do this. Format is the first one. So there are dozens and dozens of formats for data. Yet most of us who work in the APIs know maybe we can name 2, XML and JSON, 3, CSV, 4, TXT, right? We use this sort of paltry little group when we could have this vast amount. Now, do these all exist because people were lazy? No, it's because they want to model different things. We have TIFF because that models images in one way. We have GIF because it models images in another way. We have PNG and all these other ones because they have different ways to model information. Most of us today depend on this model, this application JSON, as a way of modeling this format for modeling information. It has almost no affordance. It tells us almost nothing. This is JSON. I have no idea what I can do, and I can make some intelligent assumptions in the models in my head about what is here. it turns out there are lots of flavors of JSON that have rich affordances. I'm going to pick one out called collection JSON, which is something that I helped design about 4 years ago. And it has a great deal of information and a great deal of affordance. Now, this is the exact same data that we saw earlier, but now I know what version it is and where it was from, and I know a particular data item, and I know its names and values, and I know there are things that I can do to create more. I have all this additional information because I've improved the affordance. I have a better model for the exact same data. There are lots of ways that we can add affordances. Protocol is another really important way to add more information modeling to data. So again, there are lots of possible protocols, HTTP and XMPP and FTP and MQTT and WebSockets and CoAP. These are all the sort of the more popular ones right now, and they stretch all into the Internet of Things models. But of all of these, they're really about the actions, right? They have verbs, they have action words. There's a get and a put and a post and a read and a write and all these other things. That's how we get things done. Protocols allow us to get things done. They tell us where we could go and what we could do. But even there, we're a bit confused. Very often I see this kind of documentation or this kind of teaching which says that this protocol's word called post is for creating things. Right? It turns out that's not what post is for. It has a much more mundane meaning to those of us who understand protocols. It's a non-idempotent representation of a resource. It's this other sort of much more generic thing. Our models in our head tell us it means one thing, but other models tell us it means another. So we have to think about these actions in a different kind of way. We have to think about the actions as what is it we're trying to do and how can I map what I'm trying to do to what's available to me. I'm trying to throw something at you, and I'm going to use this chair. Right? I'm just making a decision, right? I'm mapping. It turns out that some of these protocols are better than others at doing this. These are the three biggest ones. HTTP, CoAP, and MQTT all have the ability to include this action information directly in the message. XMPP and WebSockets are actually very paltry at it. FTP is actually pretty good, but we don't use it very often anymore. So these are kind of the winners. Now, most people think that HTTP is the only thing you will ever need anywhere, anytime, into all of time. But of course, we know that's not true. We didn't have HTTP 25 years ago. I'm not sure we'll have it 25 years from now, or if we do, it may not be the most dominant thing out there. It was designed 25 years ago to solve a problem 25 years ago. We now have HTTP 2. By the way, it's just going into the last stages, but it doesn't really change a lot. Now, I've talked about formats and protocols as a way for us to improve affordance, improve modeling. We're still in Shannon land. I don't have to understand anything in order to do those, right? I just have to know how to add the ability to take action or add the ability to describe what's here. I don't have to understand it. So there is one more level, and that is the semantics, actually the understandability part. Now, semantics can get people in a lot of trouble. Just as there used to be this argument about soap and rest, and you were afraid to walk into a room because people would get really angry if you actually mentioned one, there's the same argument about REST and RDF, or HTML and RDF. There's this RDF, these resource description framework patterns, right? So there's this notion that maybe I'm supposed to be choosing, or maybe there's only one way. But the idea is about semantics is to represent that internal model that we have and pass it along far enough to let somebody else deal with it. Semantics tell us what this information is, what this data is about. So I've highlighted all the semantic elements in this message. Template and data and name and href and items and version and collection. That has nothing to do with the data. That has to do with what I'm trying to communicate. Here's my collection. Here's my item. Here's the name of it. Here's the version of it, and so on and so forth. So this becomes really, really important. It turns out that there are lots and lots of repositories of semantic identifiers. This is the IANA's list of REL registries. Down below is schema.org's list of information. Here is information from the Dublin Core Committee. Here's from microformats. Here's stuff from activity streams. These are actually the big five. There are many, many more specific identifier libraries, and these relate right to what James Higginbotham was saying up here before about ontology, vocabulary, and things like that. When I want to speak to you in a certain language or about a certain subject, I'll probably pick an ontology or a vocabulary that makes sense. Right? If I want to talk about medical details, I'm not going to pick a vocabulary about finance. Right? So we have this ability to actually tell people in our models, I'm about to start talking about finance. And people can say, oh, you know, I don't really understand that. Let me hand that off to a friend of mine who knows how to talk about finance. Right? So very often when we send information back and forth, not only are we not thinking about formatting it in a way that's usable or using a protocol that tells us what's possible, we often don't think about explaining to people ahead of time what we're about to talk about. And that's incredibly important. So format, protocol, and semantics give us tools, handles with which to improve that data in a useful kind of way. And often these things can last a great deal of time. In other words, I can use the same data over a long period of time and use the same semantic information even when implementation details change. Excuse me. Okay, so what does all this mean, all this ranting? Where are we headed with this? So here's my advice. Here's the direction we're giving customers, and I will tell you the same. Start thinking about formats as a tool in your arsenal. Start thinking about using more formats that contain affordances. Don't just settle for plain XML or plain JSON or plain CSV. These are the ones that are cropping up time and time again when we talk to people. Start thinking about protocols other than HTTP. This is especially critical for when you design your system and you assume that you will actually use HTTP all the time, everywhere, on every device. This is going to be a deal breaker when you're in HTTP land, and now suddenly you need to do Internet of Things, which uses something else. If you tie a lot of your application knowledge to this one protocol, it's going to be really problematic. So start planning and thinking ahead. Finally, start thinking about semantics. Start thinking about the identifier libraries that will help other people who you've never met understand what you're talking about. Sometimes that means creating your own semantic library. Often it means using existing semantic information that you can point other people to. Now, one of the things I do when I come to an area, I do a little quick research. I say, I'm going to find out about open data here in the state of Texas. And this is the site I come up with. I was a little concerned when I saw that there were graphics, there were pictures for some of the squares, but things like the catalog and the things for developers and the apps seemed blank. That didn't really give me a good signifier. It told me a few things. Now, what I found when I started looking at various sites, and I took about 30 minutes to troll around several places, is I find a lot of cases where I'm being given raw data, where I'm being given an XSL file, an Excel file, or an HTML page, or a Word document, and I don't have any actual information about it at all. It's really just dumps. I'm really just handed a bunch of data. This is a problem for me. The only thing I could possibly do is maybe use the data and never contribute, or use the data in a way I prefer, possibly not the way it was originally intended. Now, I do see in Austin seems to be a little bit more assertive about this possibility. Austin has started using a tool that will turn data into this sort of visual display. It's like basically sort of a spreadsheet pattern, and I can do some filtering. And then I can click a button and say, export that. And now that's sort of the JSON or the XML version of the Word document I just saw a minute ago. In other words, I still don't have any interaction going on here. This is going to be a problem in the long run. This is data that's dead. This is data that maybe I could consume and abuse and lose, but it's not any data that I can enrich or enhance or collaborate with. Now, at the national level here in the US, we have a thing called Project Open Data, which is doing some fairly nice things. They have a lot of information tied directly to developers and helping developers not only find data and use the data, but also contribute to it. And in fact, a lot of the things that I was just talking about have sort of taken to heart at the Open Data projects. You can see the same information in lots of formats. In other words, the meaning is not stuck in a format. The meaning is in its affordance inside. Some of them actually offer open interactive APIs. I can actually interact with this live. It's not just a dump of information. But I have to tell you, and I'm not going to spend more time on it because we're short on time, we are way, way, way behind the curve on this. Europe is so much further ahead, especially the UK, is so much further ahead on creating usable, collaborative, and data that we can actually share and work together on. We have a lot of work in this space. All right, so wrapping up. Format, protocol, semantics. These are handles that you have in order to improve what you have and turn it from data into information. We have to remember that formats are fashion. It's, we're really excited today. We used to think that angle brackets were going to solve the world's problems. Now we've been corrected. It's curly braces. We're all set now. But be ready 3 years from now for somebody to think of something else. Don't tie your organization to a particular format. Remember that protocols are tools. There are cases when using HTTP is smart. There are cases when using HTTP is a bad idea. Be prepared to treat protocols as just tools in your toolkit and don't get caught using the wrong tool for the job. And then finally, we have to start thinking about the data that we have not as some bars of gold locked away somewhere, but as evidence of action and as opportunity to create more information and more action. We have to think of the data as just the remainder of what was really going on. That's really this is where I was. This may be where I'm going. This is where most people go on Thursdays. This is about what we do, not who we are, not the data itself. Remember, we're looking for shared understanding. We're looking to make it easier to share understanding about information and action from lots of places, like with people I've never met. Design your applications, design your APIs so that people who've never met you will be able to use them. Think about the Shannon model. Think about how much we can get done before we even worry about understanding or knowing or any of that kind of stuff. Is it the right information? Is it get from A to B? Does it have affordances? All these other things all happen without having to understand what a finance minister does or anything like that. And finally, remember what we're trying to do is turn information, but you have to take that data. We want to come up with some kind of model, and that gives us the chance to actually create information. We get something out of that. That's the goal. That's the goal. The data is not the goal. The data is actually just the seeds of what's possible. And if we think about it that way, we're going to get a lot closer to Donald Norman's notion. He has this great quote where he says, the sign of a well-designed object is when people you have never met can use it in ways you've never imagined. And that's really what we want to happen. We want people to be able to find these things and find new ways to contribute, find new ways to do things we've never thought of before. We design our APIs for that. Think about the value you have in your company, in your organization, when you give all your employees the power and the tools to find things that you never would have thought of. That's when you get real innovation. That's when APIs start to do more than just solve a particular problem, but they give you great opportunity. And that's open data. Thank you.